Revolutionary blood test reveals your organ age and disease risk. Imagine if a simple blood test could reveal the true age of your organs and predict your risk of disease and lifespan. This isn't science fiction. It's a reality that researchers are actively exploring. By examining the levels of thousands of proteins in blood samples from around 50,000 individuals, scientists are able to estimate how biologically old each organ appears. This groundbreaking approach has significant implications for understanding and managing health. When the estimated age of an organ exceeds a person's actual age, it signals an increased risk of disease and earlier mortality. Conversely, if the brain and immune system appear youthful, it suggests a longer, healthier life ahead. This method of assessing biological age is not just about numbers. It's about understanding the underlying health of our bodies at a molecular level. But here's where it gets controversial. While this method shows great promise, it also raises ethical and practical questions. For instance, how should we interpret these findings? Should they influence medical decisions? And if so, how? And what about the emotional impact on individuals who learn their organs are aging faster than expected? Let's delve into the details. Researchers have developed a sophisticated method using plasma proteomics and machine learning to create these organ age estimates. This involves analyzing the proteins present in the blood, which can provide insights into the health and aging of various organs. The study, published in Nature, highlights how these organ aging signatures can track health and disease progression. One of the key studies, led by O et al., used data from the UK Biobank to analyze the proteomic associations with genetics and health. This extensive dataset allowed researchers to identify specific proteins that correlate. However, this is the part most people miss. The complexity of the human body means that these biomarkers are just one piece of the puzzle. Other factors, such as lifestyle, genetics, and environmental influences, also play crucial roles in determining health outcomes. Therefore, while these blood tests offer valuable insights, they should be considered alongside a comprehensive health assessment. So what do you think? Could this method revolutionize how we approach healthcare, or are there too many variables to consider? Should we be excited about the potential of these blood tests or cautious about their limitations? Share your thoughts in the comments below, and let's start a conversation about the future of health and aging. When aging accelerates, the shocking truth about your body's inflection point at 50. Imagine waking up one day to find that your body has suddenly started aging at an alarming rate. It's a frightening thought, but what if you knew that this inflection point was not only real, but it could be happening sooner than you think? A groundbreaking new study has identified the exact window when the human aging process begins to accelerate, and the results are shocking. But here's the surprising part. It's not just about reaching a certain age. It's about understanding how our bodies break down over time. Researchers have discovered that the body doesn't age evenly, with one vital organ taking the hardest hit and potentially speeding up damage elsewhere. This raises an important question. Are we doing enough to protect our bodies from the effects of aging? The study, conducted by Chinese scientists, analyzed 516 tissue samples from 76 organ donors between the ages of 14 and 68. All of whom died from accidental traumatic brain injury. The samples covered all of the body's major biological systems, including cardiovascular, digestive, immune, endocrine, and skin. By using advanced analysis, the team found that the number of 48 proteins linked to disease became significantly more prominent as donor age increased. These proteins were tied to a host of conditions, from cardiovascular disease and tissue fibrosis to fatty liver and liver-related tumors. But what's really interesting is that not all organs aged equally. Protein level changes in the adrenal gland, the hormone-producing powerhouse, began showing up as early as 30. However, the real shift happened between 45 and 55, when protein expression ramped up rapidly across several major organ systems. The most dramatic changes showed up in the aorta, the body's main artery responsible for sending oxygen-rich blood from the heart to the rest of the body. As the study authors noted, temporal analysis revealed an aging inflection around age 50, with blood vessels being a tissue that ages early and is markedly susceptible to aging. One protein in particular, known as Gas6, stood out. Its levels rose in the aorta as donors got older, and researchers think it may play a central role in triggering aging throughout the body. In experiments, the team injected young mice with Gas6, and after, they found that the rodents developed clear signs of premature aging, including weak grip strength, poor balance, and visible damage to their blood vessels. According to Guanghui Liu, a researcher at the Chinese Academy of Sciences who led the study, blood vessels seem to act as a conduit carrying molecules that promote aging throughout the body. But here's where it gets controversial. The findings reinforce the growing belief that aging doesn't happen on a straight timeline. However, further research is needed to declare 50 a biological breaking point, according to Maya Oleka, a scientist at the Leibniz Institute on Aging, Fritz Wittmann Institute in Germany, who was not involved in the study. As Oleka told Scientific American, there are these waves of age-related changes, but it is still difficult to make a general conclusion about the timing of the inflection points. This raises an important question. What does this mean for our understanding of aging, and how can you use this information to improve our health? In the U.S., nearly 58 million Americans are 65 and older, and that number is projected to soar to nearly 89 million by 2060, according to the National Institute on Aging. While good health is key to independence and productivity later in life, a staggering 93% of older Americans have at least one chronic condition, and nearly 80% suffer from two or more. The study authors concluded that these insights may facilitate the development of targeted interventions for aging and age-related diseases, paving the way to improve the health of older adults. And this is the part most people miss: the importance of understanding how our bodies age and how we can take steps to protect ourselves from the effects of aging. So, we have to ask, are you taking care of your body? And are you prepared for the effects of aging? We'd love to hear your thoughts in the comments. Do you think 50 is the new old, or is this just a number? How do you plan to take care of your body as you age? When your body's aging suddenly accelerates, the shocking truth at age 50, a groundbreaking study unveils the critical moment when aging accelerates. Time may flow in a straight line, but the journey of human aging is anything but straightforward. Instead of a smooth transition, our lives experience a series of jolts, from the rapid growth of childhood through the stable phase of early adulthood, and then into a phase where aging seems to speed up as the years go by. A recent study has pinpointed a significant turning point in this aging process, typically occurring around the age of 50. After this milestone, the rate at which our tissues and organs age becomes noticeably steeper compared to the previous decades. Notably, our blood vessels are among the first to show signs of decline. The research team, led by scientists from the Chinese Academy of Sciences, states, by analyzing protein changes associated with aging, our temporal analysis indicates a notable inflection point around the age of 50, particularly highlighting that blood vessels are among the tissues that age early and are highly vulnerable to the aging process. But here's where it gets controversial. This study lays the foundation for a comprehensive understanding of human aging through the lens of proteins. A separate study has found that humans experience accelerated aging at two distinct peaks, one around age 44 and another at age 60. Humans enjoy a remarkably long lifespan compared to many other mammals, but this longevity comes with its own set of challenges. One significant drawback is the gradual decline in organ function, which increases the risk of chronic diseases as we age. Despite our understanding of aging being limited, the researchers delved into how proteins in various tissues evolve over time. They gathered tissue samples from 76 organ donors aged between 14 and 68, all of who had tragically passed away due to accidental traumatic brain injuries. These samples represented 7 different body systems: cardiovascular, heart and aorta; digestive, liver, pancreas, and intestine; immune, spleen and lymph node; endocrine, adrenal gland and white adipose; respiratory, lung; integumentary, skin; and musculoskeletal, muscle. Blood samples were also collected for analysis. The research team meticulously cataloged the proteins present in these systems, observing how their levels fluctuated with the donors' ages. They compared their findings against a database of diseases and their related genes, discovering that the expression of 48 proteins associated with various diseases increased with age. These proteins were linked to conditions such as cardiovascular diseases, tissue fibrosis, fatty liver disease, and liver tumors. The most significant changes were noted between the ages of 45 and 55, a period during which many tissues undergo considerable proteomic remodeling. The aorta, in particular, exhibited pronounced changes, indicating a heightened vulnerability to aging. The pancreas and spleen also demonstrated ongoing alterations. To validate their findings, the researchers isolated a protein linked to aging from the aortas of mice and injected it into younger mice to observe the effects. The treated mice displayed diminished physical performance, reduced grip strength, lower endurance, and impaired balance and coordination compared to their untreated counterparts. They also exhibited clear markers of vascular aging. Previous studies have identified 2 additional peaks in the aging process, occurring around ages 44 and 60. This new research suggests that human aging is a complex, stepwise phenomenon that affects different systems at various times. Understanding how aging impacts specific body parts at specific ages could lead to the development of medical interventions that ease this process. The researchers conclude, our study aims to create a detailed, multi-tissue proteomic atlas that spans 50 years of the human aging process, shedding light on the mechanisms behind proteostasis imbalance in aging organs, and revealing both universal and tissue-specific aging patterns. These insights could pave the way for targeted interventions aimed at age-related and age-related diseases, ultimately enhancing the health of older adults. This research has been published in the journal Cell.